Alright, Assalamualaikum and hi everyone. Today we're going to learn the new chapter, which is periodicity. So the first part for this chapter is the classifications of elements. So what you need to know about this chapter is basically you need to learn about how do scientists arrange the elements in the periodic table and what information does it gives you. Okay, so yeah, first thing you need to know in a periodic table is that it is being divided into 4 types of block, and this block comes from your angular quantum number, which is L equal to 0, give you S block. This is your S block, and then L equal to 1 give you P block. So everything in this area is a P block, and then it gives you D block, which is L equal to 2. In the center, this is D block, and then extended elements, which is the lanthanide and actinides, is the F block, L equal to 3. Right, so how are they being divided into all these main blocks? Is because of their valence electrons. First, because of their proton number, they're being arranged in increasing proton number, and their proton number give them electronic configurations, right? And then from the electronic configuration, we'll get a valence electrons. So basically, the valence electrons can give you the information where the element lies in the periodic table. Alright, so first thing you need to know are the terms period itself. So as you learn in SPM, periods is this whole thing. Here to that, this is called as period 1, and then you go to period 2. So then you need to know what is group. This is considered as group, going down the groups. So this is group 1, group 2, group 3, and the list goes on. Alright, so and another thing to add on is that along the period, the principal quantum number for the elements is gonna be the same, alright? Because their outermost electrons lies in the same outermost shells. So we're gonna look at the first block, which is the S block, consists from group 1 to group 2, and the group 1 is known as the alkali metal. The group 2 is known as alkali metal. Alright, and the formula for S block valence electrons is gonna be NS1 to NS2. So you can see, let's take lithium as an example. So lithium has 3 proton numbers, so you're going to have 1s2, 2s1. Then we're going to take beryllium, which has 4 electrons, going to have 1s2, 2s2. So that's for elements that have the same principal quantum number. They both going to have 2 as the principal quantum number. So if you want to see clearer how the formula works, we're going to take sodium as an example. So you're going to have 1s2, 2s2, 2p6, and 3s1. So from here you can see that these two atoms clearly comes from a different periods, because you got the higher principal quantum number for lithium is 2, whereas the sodium is 3. But then you see the valence electron configuration is still the same because they come from the same groups. Alright, so they both have an S1 as their valence electrons configurations, except that they have a different principal quantum number because they both comes from a different periods. Alright, so that's for S block. Now moving on to P block. P block is group 13 to group 18. So group 17 is a bit special because it's also known as halogen group. And then we also have group 18, which is also a bit special because it is known as inert or also known as noble gases. Right, so the formula for the valence electrons for the p block is that you'll get ns2 and p1 up to ns2 and p6. So for boron, let's say we have borons with 5 proton number, you're gonna get 1s2, 2s2, 2p1, right? And then we're gonna take neon for the last example, which is you're gonna get 1s2, 2s2, and 2p6. As you can see, the valence electron configurations is as same as the formula. And if you take aluminium for an example, basically you're gonna get the same, almost the same electron configuration, except that it ends with 3s2 and 3p1. So the difference, as I said earlier, is the principal quantum number because aluminium is from period 3. So that's for P block, and then we go to D block. So D block starts from group 3 up to group 11. It also known, the whole group is also known as transition element, and they are also famous for their colors. And then the formula is a bit different because it's gonna start with the principal quantum number lower than the highest quantum number, which is n minus 1, d1, ns2, up to n minus 1, d10, and s2. So let's take scandium as example. 1s2, 2s2, 2p6, 3s2, 3p6. So do we go with D first? No, we fill up 4s2 first, and then baru kita fill up the 3d orbitals. So it gives you 3d1. So the valence electrons, as you can see, it has a low 1 orbital that has lower principal quantum number. Alright, okay. You'll see this clearer as we try the example. So let's predict the positions of the elements from the electronic configurations. So the first one, as you can see, the outermost electron for these elements is P. So according to a table before, the formula for P is as ns2 and p1 up to ns2 and p6. Something I need to add on is that, so if you add ns2 and p1, so the valence electron is going to be 3, right? For the naming, you need to add 10, so the name for the elements that have 3 valence electrons is going to be group 13. Alright, so in this case 3s2, 3p6, right? So yeah, so 2 plus 6 you get 8, 8 plus 10 you get 18. So this element comes from group 18. In a period, the highest principal quantum number for this element is 3, so that means they come from period 3, and the block, obviously the outermost electron is P block, so it is P block. And it is also known as, if it's 18, remember, it's also known as inert gases, or also known as noble gases. Alright, the next one, also P block, but this time, are you going to see 3? Are you going to look at the electron that lies in D, or electron d orbitals, or the electron that lies in 4s orbitals? So according to the formula, you have to look at the electron that lies in the same principal quantum number. So in this case, you have to look at the 4s. So you have 5 plus 2, you got 7. You have to plus 10. So this is from group 17. The period, the highest principal constant number is 4. It's also a p block. So it's a 17, also known as halogens. The element is also known as halogen. Alright, and then looking at the next element, 4s2 is the outermost electron, so obviously it comes from s block. How about the groups? Since they are the 2 electron, that means it comes from group 2, and then the highest principal constant number is 4, so that means the element is in period 4. Now for this one is a bit special because it's the outermost electron is in d orbitals, and as we know, it's a bit complex because the formula is minus 1 d1 and s2 d1 and s2 up to minus 1 d10 and s2. So are you going to look at the 4s or the 3p? So obviously in this case you have to look at the 4s2 because the d orbitals have to have the principal constant number lower than the s orbitals, and this is the case. So the group, you just need to add the electron, 3 plus 2, you get 5, and the highest principal constant number is 4, so it is in period 4. Then the block is D block. Alright, then the last one, again, you have p orbitals that help the outermost electron again, and you have to look at the highest principal constant number, and the formula is n and p1 up to ns2 and p6. So in this case, this is gonna be 6 plus 2 equal 8 plus 10. It's going to be group 18, also known, and the highest principal constant number is 4. So it's p orbitals, so it's p block. It also known as noble gases or inert gases. And that's how you determined where the element lies in periodic table by looking at their electronic configuration and their valence electron. That's all for today. Thank you.